Hello everyone. In this tutoring video, I go over the basics of what an integral is and how you can use it as the opposite of differentiation to solve for equations involving derivatives. You may remember how the derivative is the change in y over the change in x. As the change in x approaches 0. An integral is the opposite of the derivative, in the sense that it is the summation of instantaneous changes instead of the difference, and is represented with a fancy looking S to mean the summation. Just like the change in x and the denominator of the derivative means that you are deriving with respect to the change in x, so too does the change in x in the integral mean you are integrating with respect to change in x. You may also see that the differential can be represented with d of x instead of the delta of x, but it means the same thing, the difference. If you know the derivative, you can easily get the integral, as it is a sort of reverse derivative. For example, the integral of cosine of x with respect to change in x would have to be sine of x. And the integral of Euler's number raised to the power of x with respect to the change in x is Euler's number itself, just like with differentiation. The indefinite integral is also called the antiderivative for this reason. But most of the time, when working with integrals, it involves a definite change in the x amount, which has a surprisingly simple formula, given that you can figure out the indefinite integral. The indefinite integral from point B to point A of a function's derivative with respect to change in x is equal to the function at point B minus the function at point A. So for example, the definite integral of Euler's number raised to the power of x would be Euler's number raised to the power of location B minus Euler's number raised to the power of location A. In my next tutoring video, I will go over 3D derivatives, such as partial derivatives and the gradient. and how you can use techniques from 1D derivatives to find them.